Hey guys, in this video I'm going to be taking apart my VESC-Monster 2200 watt hour 84 volt, and I'm going to be replacing the controller with this LaCroix Stormcore 100S. So what is the Stormcore anyway? Well, it's actually a motor controller based on the VESC project, and the hardware designs for the VESC is fully open source, although the hardware design for this specific one is not, but the software is fully open source. And now you might ask, Mitch, you're saying the word open source a lot, but what does that actually mean? Well, it doesn't really mean much for you, and this isn't necessarily an upgrade. It's only 120 amps peak current, but it's 80 amps continuous, and it's more than enough for a good EUC. But I wouldn't go running to rip apart your EUC to put this in. But if you've got an EUC with a broken controller, this would be a great option. Or if you've even got an outdated model that you're looking to upgrade, this would be a great upgrade. Now, this Stormcore 100S is not publicly for sale yet, but I got a few of the units, and it is a real thing, and it will be for sale. There are also a few other manufacturers making different 20S capable VESCs, so you can look out for those as well. Now, I'm not trying to pull a fast one on you guys, so in the interest of full transparency, I did write the self-balancing software for this controller, and I've already wired it up in a test configuration, so I know it's going to work on my Monster. But I'm going to take you guys for me with the journey, and I do a more permanent install and box it up nice and neat and do some real testing when it's actually properly installed. Alright, so let's take a look at my Monster and see what's going on here. Now, this is a Monster V1, which you may know had plastic bullet connectors, and then the controller side was permanently soldered on. But I've upgraded to a V3 board, and I've got the 4.5mm bullet connectors, and I kept the plastic connectors here. However, my plastic connectors melted, and I knew at the time that I wanted to get a Stormcore, so I replaced them with these 4mm nice golden bullet connectors, and those will mate up perfectly with this Stormcore. Now, I also need the Hall sensor cable for controlling the motor, and this uses JST PH, and this guy uses the JST XH. So I already had a little pigtail converter that I made for testing Gotway motors in general to see if their Hall sensors were working. So I'm good on the motor connection front. Now, this also uses a XT60, so I'm good with power as well. Now, for the LEDs, I'm just not going to have them for now, and I also need a power switch. So for that, I've got a LaCroix anti-spark 100 or 20S capable switch. It's got a 60 amp fuse, but that should be more than enough for what we'll be doing with this EUC. So I'm going to mount this somewhere inside, and I'm also going to mount this up. And this anti-spark switch uses its own push button, and this one is actually a 2-state button with an LED ring, so I'm going to have to replace the OEM power switch with this power switch, and I may eventually hook up an Arduino to control the LEDs. Now, to mount this Stormcore, I want to mount it on this heatsink, but I actually have my original V1 board that blew up, so I'm going to be mounting it on this old board, and then I will have this board nice and intact where maybe I can sell it or just save it as a backup or something. So let's get started with mounting it on this board. So here is the heatsink plate. It's got a nice heatsink on the back, but the front side is pretty disgusting, so let's clean that up. Alright, I got the Monster V1 heatsink all cleaned up. I had to sand it quite a bit, and I still couldn't even get all the burn marks out of it, so this is as good as it's going to get. Alright, I've got the Stormcore mounted up. I ended up going through the heatsink, and I just used the front screws rather than the back screws. Next, I'm going to take this anti-spark circuit, and I'm going to try to figure out how to put it somewhere in here next to the power button, and then run a cable out to this power connector over here. Got it all mocked up for testing just to make sure it's all good before I put it in up on top. Alright, since we last talked, I've got a lot done. So I got this power button installed up top, and I was able to fit the anti-spark switch up top, but it was just kind of a tight fit, so I decided I'd put it down here. It's easier to access as well. You have to take apart the whole case to get up there. So now if I turn it on, you'll see everything lights up and the switch turns white, so that's all good to go. I did all the cable management, and I also added this little Bluetooth controller. Firmware is all loaded up, so I've got my phone here. I should be able to connect. There we are, I'm connected. I got real-time data, and I'm here on the gyro, and if you see I move the wheel, it shows that moving. So everything is good to go. I'm going to tune this, get that all done, and I'll check back in once it's all working. Alright, I got an initial tune set up on this thing, so let me show that to you. Turn it on. It should just kick on. Give it a second. There it is. Alright, so you can see it's on and working. I'm definitely going to need to tune it more and dial it in, but I'm going to have to go outside and use my phone to do that. Also going to put the side panel on. I just wanted to show it to you guys working once with the side panel off. So yeah, we can hop on. Yep. So there it is. And it's raining outside, and there's a riot going on, and the city imposed a curfew. So I'm probably not going to get to test and tune it for a few days. So I'll just show clips of me riding from here on out pretty much. Alright, here are the clips of me riding around, and as you can see, it works great. It is 100% functional. I'm just zipping around, no problem, but I'm always my own worst critic, so I'm going to give you a rundown of the issues that I ran into. Now, all of these issues are absolutely surpassable, and the goal is to surpass them, so I'm not going to stop here with this level of working, which, as you can see, is already working. Now, the first thing was getting the tuning as dialed as I wanted. It was hard to get it like perfectly smooth and perfectly stiff with full power, kind of like the King songs are. Instead, it felt a little bit more like the Gotway being rough, but even worse than that, but still really not that bad. And while tuning it, I actually came up with a bunch of ideas to make it better that I'm going to try out and will be in future releases of the firmware, which is kind of one of the big benefits of open source. You really put it in the hands of the community to make what we want and what we need, and we can increment very quickly. Another issue I had was some current sensing faults that would give me a cutout if I was braking really hard at low speed, and that is apparently due to my motor not being calibrated correctly. I used the automatic calibrator, and apparently it's not good enough for this really big motor, so I need to learn a little bit more about calibrating motors so I can get rid of that. Now, my third and final complaint is that there was just not as much power as I would like, which I knew from the start that this controller was peak of 120 amps. There are controllers that have much more. There's the dual version of this that can be wired in parallel, which would have double the power, which would be absolutely insane. But these were the ones I got, and these are the ones I'm using, so it's not as much as I would like. And you can see here coming down these steps that I overpowered just a little bit on the way down, which is just not great. However, I did not cut out going down those steps, so even though I overpowered it, it worked fine. Now, in this clip, I'm just doing an overpower test, so I'm just forcing it forward and holding it. And on a Gotway controller, you would just burn it up in a second, and this thing holds fine because it actually handles overcurrent really great. It'll even do thermal throttling for you, so it's almost unburnable, I would say. You may notice that when I pulled out of it, it leaned too far back. That was my iTerm having some wind up, and I'm aware of that issue, and I will be fixing that for sure in the next release. So with all those disadvantages out of the way, what are some of the advantages of open source? Well, for one thing, I can set my side cutoff to further than 45 degrees if I want to. In fact, I have full control over all of my cutoffs and tiltbacks and everything. And in general, that is the biggest advantage of open source. You can do whatever you want with it, and you have full control. And I think that's really the future, is letting the users decide what they want and how they want their machine to work. There's so many more tuning options available and way better ways to get the feel dialed in to what you want. So hopefully, you guys will come on board and more people will be building open source vehicles, and it'll really take off from there. And if you're wondering where I'm going to be doing the test where I take this thing up to 40 miles an hour and nosedive, I can tell you right now that that test is not happening. That's just not how I ride. I did definitely take it over 20 miles an hour. I got some good speed and cruising going, and it handled just fine at speed, and that is as fast as I'm going to be going for now. So that's about all I have to say. I'll just leave you off with some more clips of me cruising around.